Hello and welcome to our webinar on NSX-T and container blind spots. Here's what to do. Today's webinar is sponsored by Gigamon and VMware and produced by Actual Tech Media. My name is Scott Becker. I'm from Actual Tech Media and I'm excited to be your moderator for this especially timely presentation. Now, before we get to today's great content, we do have a few housekeeping items that will help you get the most out of this session. First off, we want this to be an informative event for you, so we encourage any questions in the questions box in your webinar control panel. While we won't have the opportunity to do a live Q&A session in this presentation, we will get all of your questions passed along to Gigamon and VMware for follow-up. The Q&A panel is also the place to let us know about any technical issues that you might be experiencing. A browser refresh will fix most audio, video, and slide advancement issues. But if that doesn't work, just let us know there in the Q&A and we will provide further technical assistance. Second, in the handout section of your webinar control panel, you'll find that we're offering several resources, and I'd especially like to call your attention to a link about deep observability into VMware workloads, a data sheet on the GigaView Cloud Suite for VMware, and a PDF about Gigamon network visibility monitoring. We've also got a link to the Gorilla Guide Book Club where you can get access to Actual Tech Media's great printed resources on technology topics, as well as a link to the ATM Events Center, which has our calendar of upcoming events. So I encourage you to access those resources now and share them with your friends and colleagues. Third, at the end of this webinar event, we will be awarding a $250 Amazon gift card to one lucky registrant. Of course, you must be in attendance during the live event to qualify for the prize. Official terms and conditions of today's prize drawing can be found in the handout section as well. Just scroll to the bottom and you'll find the prize terms and conditions link there. All right, and with that, let's get into today's fantastic content. It is my pleasure to introduce you to our presenters today. We have Bassam Khan, who's Vice President of Product and Technical Marketing Engineering for Gigamon. And we have Kevin Brady, who's Partner Staff Solutions Architect in the Office of the CTO at VMware. So now I'll turn things over to Bassam to get us started.
Hello, everybody. Welcome to our webinar about complex hybrid cloud applications. I am super happy to be here with Kevin, an awesome, intelligent person, but an awesome human being as well. So we're going to hear from Kevin in just a minute. I'd like to jump right in because we have a lot of very, very cool stuff to talk to you about. There will be actionable intelligence for you for short-term actionable, strategic actionable. And then also I'm going to give you a demo of a cutting-edge technology that is relatively new, as in just the past few months. So this is something I'm guessing you probably have not seen before. So by the time we're done today, 4 things you're going to walk away with. Number 1, we all deal with modern applications. These are hybrid applications. These are typically multi-tier applications. And we're going to see why those applications are complex, at least from a monitoring, securing perspective. One way to get rid of complexity, or at least address the issue of complexity, is by bringing consistency. Consistency from a visibility perspective, from a management perspective. We're going to hear quite a bit about that from Kevin. Lastly, from Kevin, we're going to hear about full stack enterprise observability and its role in helping you remove the complexity, but also ensure performance, troubleshooting, and everything else related to maintaining, monitoring, securing those applications. Let me show that off. Lastly, I will, from that point on, I'll take over and I'll talk a little bit about Gigamon, how we bring the network visibility, and show how we complement everything else you get in your VMware environment by bringing a brand new level of visibility based around network telemetry. So with that, before I start, let me just say one thing about myself. My name is Bassam, and I started my career in IT, working for an investment company in Boston. Came to Silicon Valley on my anniversary. My wife and I came out, and almost as a joke, I gave an interview at Oracle. Hopefully they're not listening right now. And I wasn't that serious about the interview, about the job, because things were going great in my company, but ended up getting an interview and they ended up liking me for whatever reason. And that was in the late 90s, and I've been here since then. I tend to do startups around security side, and Gigamon was the first non-startup that I've joined in a very long time. The base on your right-hand side, I just put the picture up just because in my 50s, I have picked up bass guitar just a few weeks ago, literally, and I'm just totally grooving to bass playing. So that's kind of my hobby, my interest. I kind of wanted to show that side as well. So with that, let me hand this over to Kevin. Kevin, all you.
Well, thanks so much for that great introduction, Bassam. My name is Kevin Brady. I'm a staff solutions architect here at VMware, and I've been with VMware for 10 wonderful years now. Prior to my career at VMware, and unlike most VMware people, my background is in development. So anybody who remembers something called Unix, which is what predated Linux, that came out of AT&T Bell Labs, and I was part of that development group. So my background is very much focused on development and operating system development. I am a part of what's known as the Tanzu Kubernetes Subject Matter Experts team, Tanzu being VMware's suite of products that are built around our modern applications offerings. And I have also been part of the Hands-on Labs team for 7 years. So anybody not familiar with VMware Hands-on Labs, it's one of the great free resources that VMware makes available to you to try out our products, and especially in the Tanzu space. Next slide, please. So cloud and containers, as Bassam mentioned, it's now all around apps, modern apps, and customers are now looking at cloud. And they're looking at cloud for a lot of reasons. A lot of them are looking for improved resource utilization. They can just go out to a AWS or an Azure, and they can spin up an application in a matter of minutes without having to wait for an IT team to spin up an entire virtual machine or image a server for them. And most of the customers say that by going out to it, they really take advantage of a lot of the functionality of the cloud. And the other advantage of containers is that it really gives you a wide breadth of software in the open source space. So for those of you not familiar with what open source software is, it's essentially free software. Think about Linux and the Linux revolution, where I can go out and I can grab Kubernetes from the open source community, and I can spin up Kubernetes with a network and some type of load balancer and ingress controller in a matter of minutes. Next slide, please. But I talk to a lot of customers. I do a lot of workshops. I talk to a lot of customers. I work in the VMware booth at multiple shows. And when I talk to customers, what I find is it's not so much the initial, I want Kubernetes on my private cloud. It's when I start to scale those applications and I start to scale them across multiple different clouds. So I might have an on-premise private cloud, but I may want to scale out to possibly AWS in the US, but perhaps something like Azure or Google Cloud at my sites in Europe or Asia. And what we find when talking to customers is that the further I sprawl, the more sprawl I get, the more difficult it is to actually do any reasonable amount of tracking on those applications, specifically in the areas of network security. Because a major concern from a lot of my customers is I move out to cloud and my developers are developing out in the cloud. My developers aren't security experts. They're not setting proper firewall rules. My network team, my security team doesn't have great insight into what's going on outside my actual data center because I've sprawled out to multiple clouds. That means multiple tools. That means multiple data sources. And that all makes it very difficult for my security team and my network team to really verify that I'm in compliance with any of my corporate guidelines. So what we find is that there's what we think of as a skill gap, where my on-site developers may be very, very well versed in vSphere, but they may not have that same level of knowledge when they go out to a cloud, an AWS, an Azure, or Google, or an Oracle cloud. And most of our customers do not have any Kubernetes expertise. They don't really know how to stand it up. They don't really know how to deploy it. And they find that managing it becomes a real nightmare. The day one operation, standing up Kubernetes, maybe my development team does it, maybe my platform team does it, but inevitably hand it back to the IT team. And the IT team now is tasked with managing a very vast framework because they have potentially inconsistent Kubernetes platforms. There's certainly different management paradigms. So anybody that's used native AWS, native Azure, native Google, will realize that the management paradigms, the reporting paradigms, the frameworks are all very different from what they're used to with the on-premise cloud. Next slide, please. Yeah, thank you. So how do I manage all this? I have Kubernetes. I may have a Kubernetes cluster that's sitting in my on-premise private cloud. My developers have stood up an instance that's sitting out in Azure or Google. I might have some edge computing because I want to bring my application stack out closer to where the customer is. Maybe I'm a convenience store or a large retailer that has a lot of edge computing going on. How do I manage all this? Because it's disparate platforms, potentially different versions of Kubernetes and different tools. And what I'm looking at is a fractured data plane. Next slide, please. Next slide, please. So what I really need is, could you build it out one more slide, please? What I really need is some type of unified observability. So I want a global control plane. I want to be able to look at all these microservices running across all these different instances in cloud. I want to be able to look at them in some unified manner. So if I have an issue, and anybody who's been in IT knows that when your phone starts to ring off the hook, it's inevitably a problem. So say I have an application that's running, maybe I'm a ticket master, and I've just scaled up, and all of a sudden I find out that there's a problem someplace in my application. Customers are getting spinning wheels or they're not able to connect. My developers say that they haven't changed a line of code in 6 months. And now as the IT team, I'm left to try and figure out and quickly figure out where the disruption is. And as I look across my private public clouds, my edge locations, how do I pull all that information together in a coherent fashion? That's going to allow me to very quickly determine where my hotspot, trouble spot is. Next slide, please. So as I mentioned, what I have is disparate teams. I have development teams. I have platform engineers and SREs. I have security teams. I have network teams. I have my business application team. I have my application that's spread out across multiple clouds, multiple locations, multiple time zones, multiple countries. How do I do real-time ingestion of that data? How do I go to a single source of truth, a single data pool, where I can go and I can get real-time information on not only can I get metrics and traces, network traces and logs, but how do I do all that from one single source of truth and do it real time without having to dig through 4 different logs on 5 different clouds with a bunch of different tools and coordinating a whole bunch of different teams, because no one team has that insight into across the entire broad spectrum of my microservices application. So what I really need is some form of network and data and application visibility, a single source of truth, a single data plane. You can go ahead.
Very cool. Thank you, Kevin. Okay, so we're going to jump right in on where Gigamon comes into all of this. And we offer what's called a deep observability pipeline. And I'll dive deep into what that actually means in a couple of slides. But first, we're going to turn the clock back to the late 2000s or so, roughly. on how Gigamon came to be. What was the core function that we provided? So back in the 2000s, even in the 1990s, if you ask somebody, what does your infrastructure look like? Chances are you're going to get a network diagram that more or less looks like this. To this day, that network diagram and the network itself, that infrastructure is still there to a large extent. This is kind of what we mean by a hybrid cloud. Now, that's infrastructure. Then there's a whole slew of tools needed to secure, to monitor, to optimize, to troubleshoot anything that's going on in the infrastructure, particularly applications. And all of these tools you see here, and this is slightly dated, but there's a lot more tools, need access to one thing to do their job. That's network traffic. That's the realm that Gigamon lives in. It's network communications, network traffic. So as a result of the network and the infrastructure being very complicated and distributed, these tools need to plug in everywhere in order for them to do their job. If a specific tool is not seeing some communication happening, let's say at a branch bank office, at a remote bank branch somewhere, if it's not seeing the traffic, then that's a blind spot. And blind spots are welcome places for the threat actors. And blind spots are really painful places from a troubleshooting perspective. That's where Gigamon came in. We said, rather than having your tools go out to fetch the data, plug in Gigamon one time. You usually tap into the network in various locations of the network, spine, leaf, depending on where we want to pick up the traffic. Then you get to send the data to the tools and not have to send your tools to go get the data. Simple proposition. And Gigamon's built an entire business and new innovation over the past 15 years based on this concept of centralizing all data in motion. And once you've centralized it, we can do some pretty wonderful things. Like we can deduplicate packets, because there's always a lot of duplicate packets as an artifact of any infrastructure. Typically, when we go into organization, we see 30, 40, 50, sometimes more % of duplicate packets. And what happens to these tools when you take out duplicate packet? Does it get less effective? Absolutely not. There's no value in duplicate packets. What it does do is it takes away the noise, improves the signal to noise ratio. And by taking out 50% of duplicate packets, you're instantly doubling the capacity of these tools. By centralizing other functions like decryption, you're instantly relieving 60, 70, 80% of capacity that otherwise these tools would have to spend in that decryption function. Oops. So that's where we came from. So where is the world headed? So we have been talking to, I personally have a lot of customers. I personally have talked to over 100 one-on-one customer discussions over the past year, couple of years. So we have a view of the future, and the future, our view of the future is not based specifically on technology, but it's based on these different personnel within any organization that's responsible for building, but more importantly, deploying, maintaining, monitoring, securing hybrid cloud applications. And we took a look at the personas, the work that they do, the tools that they use to do the work, and then what kind of telemetry comes into those tools. Generally, two different categories of tools. One category is the traditional data center that's migrated over to doing similar functions in cloud, in virtual environments. And these are the types of tools that typically look at very low-level network traffic, particularly the security tools and the performance tools on top. They can handle raw packets coming in. The tools on the left-hand side are more of the modern type of tools, and the ingestion mechanism there typically tends to be metrics, events, logs, and traces, like Kevin just talked about. Now, there's some level of granularity, some level of context that's lost when a log file is created that you would otherwise get by having access to packets, except the tools on the left-hand side, they cannot ingest packets because packets are too low level. There's too raw data coming in, too high volume data coming in. That's just not what they're designed for. And that's where Gigamon came in. When we talk to customers, we find that there's a separation of the functions and the capabilities of these different personas, these different functions, based on the type of tools that they use. And as a result, they're not able to do some of the security functions, some of the more type of troubleshooting functions where you need access to that granular data. That's why we've built this notion of deep observability pipeline. The first function that's tied to the previous spaghetti wire diagram that I shared shows that we are able to share or broker network packets to the tools that can handle packets. Sometimes it's NetFlow metadata, high-level data, but more often than not, what we find is that most of our customers use this to consume packets into those tools. What's new here is this entire spectrum to the left. It's the ability to extract out intelligence from the packets, and rather than sending it over as packets to the tools on the left-hand side, Gigamon's deep observability pipeline will convert that into metadata, extract important data, again, further improving signal to noise, and all of a sudden be able to send this data and have the tools on the left-hand side be able to consume this data. Now, that's where deep observability pipeline comes in. The term observability, it's non-intrusive. So we're looking at the data remotely, and we're coming into being able to view the data. Now, the deep part of this is the notion of we provide a lot more context than otherwise available. We provide a lot, part of this is through deep packet inspection. Part of this is really about the context that we provide that we can glean from network traffic. Third point, pipeline. I'm going to give you a demo of Gigamon in just a minute. You're going to see that we are not an end user analytics type of a tool. We are a pipeline. Our job, our reason for existence is to be able to provide visibility and new types of metrics and telemetry to the different systems that you currently use for your analytics, for your queries, for your dashboarding, and all of that. And I'll, again, give you a demo of all of that. So coming back to the previous diagram a little bit, double-clicking on it. So we have a whole set of partners we work with. And then there's a set of workloads, set of partners we work with where the workloads are running. The partners on top are the analytics tools. They're the reporting tools, the security, monitoring, and so on. And applications are running on the bottom side here. So there's 4 basic functions that Gigamon really does at a high level. We access the data based on any kind of local access mechanism. If it's running on VMware, we'll support NSX-T, we'll support VMware's automation, orchestration, whatever our customers prefer to do. If it's AWS, we support Terraform, same thing with GKE, with Google, same thing with GCP, same thing with Azure, and so on. Going into the container level access as well. So it's container-to-container communications, pod-to-pod communications. So again, what we're doing is we're offloading the function or the responsibility of the developer or the DevOps team or the SREs from having to extract out data and learn the nuances of each of these different platforms. And we're making that much, much easier to, again, bring reducing complexity with a consistent type of a visibility. Again, I'll be demoing some of this to you. Now, this slide gets a little bit deeper into it. So the first part is that we offer our solution either as physical form factor or virtual form factor. So we have every range of tapping tools and physical tapping tool for any kind of network speed, virtual taps. And this one single binary universal cloud tap actually is able to go in, and the single binary is able to access traffic from every type of virtual platform out there, including all of the major container platforms. Then we'll transform the traffic. So I talked about the decryption function, but there's a lot. I also talked about deep packet inspection, but there's a lot of different functions that we perform to help transform the traffic into something that's more usable. Once we have transformed it, we'll run a number of optimization capabilities. I mentioned deduplication, but you can also do, for example, application filtering to say, this is layer 4 through layer 7 filtering to say, the tools on top, especially the ones on the right-hand side, they may not need to see Spotify traffic. Why clog up those systems with YouTube traffic coming in? Although some security tools will want to see YouTube traffic. We can do flow slicing, so we can say send the first 10 packets, ignore the rest because the tools ignore the rest. There's a lot of those capabilities in our system. And then we will share that data, we'll broker that data to tools on the right-hand side, but rather than just sending the fire hose of packets, we send it as through load balanced, and we have something called port interface compatibility. So if you have a 10 gig tool that runs, and you upgrade your network to 40 gigs, we will support that compatibility so you can still keep using the tools you have been, which is actually a really important part from for our customers when they're migrating traffic and virtualizing more and more of their applications. The tools on the left-hand side, as I talked about before, cannot ingest packets. So this is where the metadata comes in. So we're sending it over JSON, Kafka, anything that the tools are able to ingest. And then we also have integration into it. So this is where I'd switch into a little bit of a demo. So bear with me. So first thing I'm going to show you is this item on the right-hand side on how Gigamon will send the data to the tools on the right-hand side. So this is our user interface. I got a lot of windows open here. Make sure I'm in the right window. This is our user interface. And so basically our notion is that you can grab traffic from anywhere. So these are workloads. For this specific instance, let me just go into an observability pipeline workload that we're looking at. And so the picture on the left-hand side or right-hand side here, if I can give my direction right, what this basically shows is that Gigamon's tap is able to see three different, probably this is VPCs in this case, I believe, workloads that popped up. If there's a 4th, 5th, 500, 5,000th different EC2 instance or workload, any kind of virtual workload pops up, we have something called automatic target selection. And our foundational job is to make sure that we're seeing traffic popping up. When that traffic scales back down, we also start bringing down the traffic to optimize our customers' resources. One thing I forgot to mention that we are a software and a hardware solutions vendor. So it's not a SaaS service. Our customers have all of these tools to be able to do the work. So the key point here is that we provide a high-level view of a hierarchy of the workloads, and then make sure that as new workloads pop in, they're showing up. So this observability, the high-level observability, is really this thing here. So this is all the traffic coming in. We're sending it here. So let's say, based on the picture on the right-hand side, we've got an extra hop network detection response tool. So what I can do is I can literally drag and drop extra hop over here, and I can draw a line coming from extra hop to the tool. It's like a Visio-like interface, but I may want to do something to it. So let's say I want to deduplicate the packets. So simply drag, drop it over here, and I drag it over here. So now with this automatic step, we're seeing all of the network traffic popping up, all the VPCs popping up, that traffic being sent in a deduplicated fashion to the tool. If we wanted to have some kind of a masking in the middle as well, I simply kind of put that masking in the middle so you're able to mask out PII related information for compliance purposes. There's a lot of functionality. I won't get more into that. But the key, there's also decryption, of course it logged out, decryption capability, which basically allows us to decrypt physical or virtual. Physical, we go up to TLS 1.3. Sorry, I'm clicking all over here. Flow maps and go over here. So I'll skip over this for now, but basically we're able to decrypt all the way up to TLS 1.3 or 1.2 with PFS, and make sure that we're offloading, allow our customers to offload that decryption function from all of these different tools. So when it comes to sensor deployment for NDR, when it comes to IoT security system sensor deployment, it just becomes night and day simpler. So those are all the tools on the right-hand side. What about the tools on the left-hand side? Well, this is a case where we will actually go through some deep packet inspection, and we'll do some metadata extraction through our deep packet inspection. So these tools on the right-hand side are collecting intelligence based on agents that are deployed. An agent could just be a syslog file coming in from the managed hosts. And with that, our partners are able to build out dashboards and widgets and queries and alerts and all of that. What we do is we provide sort of the bottom-up view or the outside-in view. What that means is we will tap the traffic, as I showed you in the previous couple of slides. We have what's called V-Series. This is our box running at our customer site. And that will, through deep packet inspection, export out metadata in all the formats that I talked about in the previous slide. Now, we have a completely different perspective all the way down to the network level communications. And the agent may not be able to see that far down the OS stack and then the OSI stack and be able to see what's really happening on the network. So while a syslog might say, I'm doing this thing guarantees that syslog, what's being communicated over the network, is really what's really being communicated. This is a really important point, not just for managed hosts, but for unmanaged hosts as well. So this could be using the current tools. I can look at a BYO device. I can look at an application that I didn't even know existed. The API was still being used, even though the developers, left the company maybe years ago. It can be an IoT device. Why is the surveillance camera talking to, whatever application or whatever workload and so on? So there's a lot of different use cases. I'm going to touch on some of these use cases. Again, not just for managed hosts, but for all hosts out there. And this is where Gigamon's application intelligence comes in. And what that is basically is the second tab here, and sign back in. What this is basically is our ability to, through deep packet inspection, I'm sorry about that, wrong VM. Through deep packet inspection, be able to provide layer 4 through layer 7 type of information. There's two use cases for that. The first use case is filtering out traffic. So let's say I have Spotify traffic. I can say, click on Spotify, or there's a family of traffic like streaming media. I can say, don't send that to all my tools. Let's say there's a Microsoft Windows updates, which tends to be very large files. I can say, don't send that to my SIM or whatever long-term storage tool, NDR tool that we might have. But what I will dive into here is our metadata intelligence. This is where we're extracting out over 5,000 different attributes about the metadata. So we will do the deep packet inspection once. And in this case, we're sending some of the data to logarithms, some of the data to a SIM, some of it to observability tools, also to Elastic. What are we sending? Off the 5,000, if I open up network traffic, I see that these are the different protocols that we're sending. So we send DHCP-related information, we send TCP-related information, we also have web-related information. So these are all grouped together. So why is this important? So this is all low-level capabilities, Bassam. What do I do with this? And I'm going to give you a demo. But before I jump into a demo, let me just talk about one key point here, one quick point here, which is here's my TCP. And there's a lot of different attributes. There's 29 different attributes. And here I have RTT, so round trip time for my TCP. Down here, this is HTTP. I also, somewhere right here, I also have an HTTP round trip time. Now, the user calls up and says, my app's running slow. What do the app people do? They pick up the phone, operations, network team, NetOps, you guys, the network's slow, So this is just a microcosm of an example. By providing this information into the tool that the app owners use, they're able to see that, hey, my overall application round trip time has spiked, but my TCP round trip time has stayed flat. My HTTP round trip time spiked. What does that mean? If the TCP stayed flat, our HTTP round trip time spiked, that means it's not a networking issue. So now they can actually find this out themselves without having to go through and call up NetOps and other teams. So here we've got a whole bunch of tools, and we're currently working with VMware, so I cannot demo VMware yet. This is, as I mentioned before, really new technology. We launched this at the end of 2022, coming into 2023. So it's a very, very new capabilities. We're building out our partnerships right now. So these are all metadata attributes coming into this particular dashboard. This particular dashboard is built by this application is New Relic application. We are Switzerland when it comes to what kind of tools our customers use, and you can really use the existing tools that you have. This is Dynatrace coming into Dynatrace. I'll come back to that. This is the same data coming into New Relic, and don't worry if I'm going too fast, I'll come back to the use cases. This is the same data, probably logged out by now. No, okay, good. Coming into Sumo Logic, by the time it loads. This is the same data coming into Splunk. This is the same data coming into, I guess, two different dashboards within Splunk. So what is the type of data coming in? So in this case, he can get all kinds of security and performance related information. And we have something called starter packs, which lets you pick what category of information you want to send. I'll actually show you the starter packs if we have time at the end. So what I wanted to mention here is we get to see what type of SSL TLS ciphers are being used, and which is quite helpful to know, are there any old ciphers or weak ciphers being used? And almost 100% of our customers, when they turn on this capability, they're like, whoa, I didn't know I had SSL 1.1 out there still in use. And there's always some level of old usage. We also show expiration. So when will my certificates expire? And these are expired. So if a certificate's going to expire, what that basically means is that that application, let's say that certificate expires next month, that application is going to go down next month. So this is a way to be proactive and avoid the troubleshooting in the first place and be able to seek out areas of improvement and sort of problem when it happens. DNS servers, DNS response codes coming back. So again, there are over 5,000 different attributes. This is something that Dynatrace has been building with us. So this basically shows the top type of traffic coming in. And again, this is not just for managed hosts. This is the entire infrastructure, any host that's speaking on the network. Really important. It's not just for managed, it's for unmanaged hosts, anything on the network. BGP status, or what kind of error codes am I seeing out there? Round trip time. So what applications have a high round trip time? And of course, you can sort, you can set up alerts, queries. And this is the type of thing that Gigamon does not get into. We're not an analytics tool. We're not a security tool, but we provide a level of security that's just super important for all of these tools. What type of DNS queries are being made, and what are the searches sort of resolving into? So this could lead to DNS hijacking, even DHCP hijacking and honeypotting or poisoning. I forget what the term was. Within a web page, what were the different widgets within the page? What were their load times? Are there, and I guess our partners have been building this out, and are there any queries being hijacked or diverted over to Russia? So I guess they must have picked the right country code of Russia specifically. Are there any degraded performance going on here? TCP checksums. And are there any, like as I mentioned, any old ciphers being out there? What SSL versions are being used out there? So it's a single view for the app owner to be able to know what's going on based on network visibility. So they don't have to go into 14 other tools, and it's that telemetry from the low-level network context is coming in here. Is there any crypto mining? There are about 13 different crypto mining traffic detection that we can track out of the box. And this is important because crypto mining is really hard to find. It's not a security threat, but yet it's a very expensive thing to pay for whoever owns the public cloud environment. P2P traffic. This is important. Non-standard TCP ports being used. So in this case, DNS, in this case, SSH port. So we look for port 22. I'm sorry, SSH is port 22. If there is, if I make an SSH connection, let's say over to Kevin's machine, and I have his credentials, he's probably got port 22 blocked because that's, basic security practice. What I could do is I could just overwrite and send SSH connection to go over port 443. Well, no one has 443 blocked typically because that's just web traffic coming in. And what we do is we provide, if you look at the logs, it'll say Bassam connected to Kevin, and it was went over traffic 443, port 443. What we do is through deep packet inspection, we say, yes, Bassam connected to Kevin, the source IP, destination IP, it was 443, except this was not web traffic. This was SSH traffic. This was not HTTPS. It was SSH traffic coming in. Is this a threat actor moving around? Maybe, maybe not. But it's definitely something of interest. Why is there non-standard port use cases happening? So again, I kind of pause there. The same thing can happen in whatever tool that you may want to do. Some of our customers are building out zero trust based dashboards. Some of them are building out dashboards around zero trust security functions, APM and PMD type of functions, and so on. So this is really opens up a lot of capabilities for our customer. So with that, I'm going to get into the closing slide. So hopefully this was helpful to you. As Kevin talked about earlier, of different personas building different applications, and the applications getting more and more complex because they're so distributed, because the variety of the application platforms is growing every single day. If a developer says, I'm really comfortable with this in the GKE environment, somebody else that AK is the way to go for us, they're going out and building those environments. So being able to have a consistent view through full stack enterprise observability, through the tools that you have, and also through deep observability pipeline, which is what Gigamon brings, the network perspective. So when you bring the two together, you're really able to get a much more holistic view into your applications that just makes troubleshooting, monitoring, performance troubleshooting, security use cases much easier to handle in this kind of a complex hybrid cloud environment. So with that, I would like to very much thank Kevin for joining me at this session, and it was truly a pleasure. And I would also like to thank all of you for taking the time and staying with us. Hope to see you soon. Take care. Bye-bye.
All right, thanks, Bassam and Kevin, for putting together a really informative presentation there. We really appreciate your time today. And we do have a poll for everyone this time. We're wondering what additional resources you'd like to receive from Gigamon about the Gigamon solutions that you've heard about today. So, the options there include data sheet, technical white paper, customer case study, pricing details, personal demo, like to try it for yourself, already a customer, or nothing at this time. You can choose as many of those options as you'd like, and Gigamon will get all of those to you, or set up the demo or whatever you'd like to do. So I'm going to leave that up here for just another minute to give everyone a chance to answer. And in the meantime, we will get to our Amazon gift card prize drawing. So the winner of our $250 Amazon gift card today is Matt Wolf from Illinois. Congratulations to Matt Wolf. We'll be in touch to get you your card. And Dean and Miles, thanks for the feedback about the presentation. Really appreciate it. I've got to agree with you guys. It was really interesting. Okay, so thanks to everybody who filled out the poll. We are going to go ahead and wrap up. I will give one quick reminder about all those great resources that are in your handout section, as well as your last chance to grab those. But with that, on behalf of the Actual Tech Media team, I want to thank Gigamon and VMware for making this event possible. And thanks as always for attending and for your great questions that we will be passing along. That concludes today's event. Have a fantastic rest of your day.